Okay, let's have a look at running a regression in Minitab. I've got the Burger King data here in this file, and if I scroll down, there are 122 items on the Burger King menu. God, I didn't know they sold so many things. Anyway, in column C1, we've got total fat. Column C2, we've got protein. Both of them are expressed in terms of grams. And really the question is there a relationship between total fat and protein? And if there is the relationship linear? Because when we do regression in this course, we're really only interested in whether that relationship looks linear. Okay, to get the regression, we go to the Stat tab. You're going to take the second one from the top, Regression, and we're going to use Fitted Line Plot. And shortly I'll have a look at this second one as well, but most of your work is going to be done from this one, Fitted Line Plot. Okay, window opens up, and we have to decide what's going to go on the X and what goes on the Y axis, and that's really critical. Okay, we are trying to predict the total fat of a food item based on the amount of protein that it contains. The protein is the predictor variable. Predictors always go on the X. So take the amount of protein, and we want to determine from that what is the expected or predicted amount of total fat. So total fat goes on the Y. In a regression, this is always referred to as the response, and your X variable is always the predictor. Now, notice in Minitab you can check to see whether you have different models, whether you have a linear, quadratic, or cubic. We're really only interested in whether the model is linear. There are other buttons in here that we're going to use in a subsequent video, but for now I'm just going to say OK and let Minitab do its thing. Okay, so I get this, and what this does is gives me a summary of this whole regression model. First of all, I get a scatter plot, and on this plot it shows me the line of best fit. Minitab has calculated that line, and that line is the line that should give us the smallest, what's referred to as the sum of squared errors. So if I take every data point and I find how much does it deviate from an actual data point down to a point on the line, my line of best fit is the line that will give me the smallest sum of all these squared deviations. Okay, now we don't care. Minitab is doing all of this in the background. All right, when I look at this scatter plot, one of the first things I need to ask myself is, does this look like a linear relationship? And if it does, is it positive or is it negative? Now, generally speaking, this looks like a positive relationship. As the amount of protein is increasing, so too is the amount of total fat. The points more or less look like they form a linear pattern. I know there's a lot of spread in these points from the line, but that's to be expected because let's face it, the amount of total fat in a food item is not only determined by the amount of protein that might be in it. There's loads of other things in food that could account for the total fat. So I'm not surprised that I see a lot of scatter on this line. Okay, so generally speaking, it looks reasonably linear and it looks like a positive relationship. Minitab gives me the equation for the line of best fit. Here it is. So here's my Y variable equals, here's my Y-intercept, plus the slope of this line, 0.95 approximately, times the amount of protein. Minitab also in the box over here gives me some important values that I need to have a look at, and I need to know what they mean. The standard deviation, first of all, is 10.3. Now, what does this really mean? This is referred to as the standard deviation of the residuals. And really what it means is that if I look at all of these data points collectively, and I look at how much do they deviate from the line. So if I take any point here and measure its vertical distance, and it's always in the vertical direction from a data point to a point that would correspond to it on this regression line. Some of my points are above the regression line, so they will have positive residuals, and some of them are below the line, so they'll have negative residuals. And if I took all of those, squared them, added them all up, divided by number of data points minus 2, and took the square root of the whole mess, I would get the standard deviation. So what this really tells me is that on average, these data points, or my data, deviate from the line of best fit by 10.3 grams of total fat. And really what that's telling me too is that if I were to use this equation and plug in some amount of protein and solve for the amount of total fat, my prediction is probably going to be off on average by 10.3 grams. That's how much of an error I'm likely to have. Now, the R-squared value is 62.3%. Minitab also reports an R-squared adjusted. In this course, we are not going to consider the R-squared adjusted. We're only looking at R-squared. So the R-squared value is 62.3%. Now, what does that really mean? And R-squared, by the way, is referred to as the coefficient of determination. Okay, it tells us that 62.3% of the variation in the total fat is explained by the amount of protein in the food item. So 62.3% of total fat can be explained by the amount of protein in the item. And then if I took 62.3 minus 100, what's that going to give me? That's going to get me 37.7 approximately, so around 38% of the amount of total fat in these food items is not explained by my model. The perfect R-squared would be one where the R-squared was 100%. And if R-squared was 100%, and sometimes you will see it pretty close to 100%, your points will fit pretty well bang on to this red line. There will be very little deviation of points from the line of best fit. And the other thing to note too, by the way, is as your points get closer and closer to your line, right now I got a lot of scatter, but if my points were closer to this line, my standard deviation would also be a lot smaller. So if I had a really great looking fit, S becomes a small value and R-squared becomes a higher value. Of course, the highest value it could be is 100%. All right, so that's the information that I get out of my Minitab printout. I'm going to minimize this for a second. And if I have a look here at what's being displayed in the sessions window, Minitab is giving me the equation for the line of best fit. It gives me the standard deviation of the residuals and the R-squared value. This business right here with the analysis of variance, we are not going to talk about right now. Okay, the other thing that you're going to find in your notes is a relationship between R-squared and the Pearson's correlation coefficient. Now, if I want the Pearson's correlation coefficient between these two variables, I'll go stat, basic statistics, I'm looking for a correlation. I pick these two, say OK, and what is my R value? This is my R value right here, this 0.789. So my R value is 0.789. If you put that in your calculator, 0.789, and you squared it, you would get 0.623. Minitab expresses the R-squared as a percentage, and that's typical of most software. So R-squared and R themselves are related to each other. Now, a big piece of doing regression analysis is to check the residuals, and I'm going to do a separate video for that. Okay, I forgot to show you. If you want to get Minitab to plug in values of protein and solve for total fat, you can't do it from the fitted line plot as we just did. So let's just go have a look at that. Somewhere in your notes it talks about plugging in 29 grams of protein into this equation, doing the calculation, and finding out what is the predicted amount of total fat based on our model. Okay, now you could do that yourself with your calculator, but if you were lazy, you could go into the second regression window, and this gets a little bit fiddly. You hit Regression, Fit Regression Model. Okay, it wants to know what is the response, and it's got it as plural. We only want one response. That's our Y. And you're going to use this box that says Continuous Predictors. Now, if you were doing a really fancy regression, there might be other predictors, but we are doing very basic, simple regression. The Y variable goes in the response, and the X variable goes in the protein. Now, I'm just going to say OK to this. And Minitab's going to give me a whole bunch of old stuff, which I don't really care about. But the reason I have to do this is now I have to go back into regression, and once you have an X and Y specified in your regression model, you can now come down, third one in the list, where it says Predict. Okay, window opens up. Minitab now knows it's using total fat based on, right here, protein. And we are simply going to enter an individual value, and I'm going to enter it right here. The question was, how much fat would there be if the protein content was 29 grams. Now, I could enter a whole bunch of other numbers here if I want, but the question's only asking me for 1 point, so fine, say OK. And when I look right here, what does it tell me? There's my equation again. Minitab is telling us that when it sets the amount of protein to 29 grams, and it throws it in here, multiplies it by 0.95 and adds 6.652 to it, what will be the value that fits on the regression line? It will be 34.2. So you will see reference to 29 and 34.2 in your notes, and this is how you would get it in Minitab. Now again, you don't have to go through this whole rigmarole. You could whip out your calculator and calculate this yourself.